Europa, one of Jupiter's most fascinating moons, has been a subject of intense scientific interest for over 400 years. Discovered by Galileo Galilei in 1610, it has long been an object of curiosity, but recent discoveries have propelled it to the forefront of astrobiology research. Europa is now considered one of the most promising locations in our solar system in the search for extraterrestrial life. Beneath its icy surface, scientists believe there is a vast ocean, which could potentially harbor life in ways we have never imagined before. The question that has intrigued humanity for centuries, whether we are alone in the universe, may have its answer in the frozen depths of this celestial body. As the scientific community continues to unravel the mysteries of Europa, it seems increasingly possible that the distant moon may hold not just answers to our deepest questions, but also the keys to understanding life's existence beyond Earth. For centuries, the idea of life existing elsewhere in the universe was purely speculative, a notion confined to science fiction. However, the discovery of Europa's ocean changed the conversation. We now know that beneath its thick ice crust, Europa harbors an ocean that is thought to be up to 100 kilometers deep, potentially holding more water than all of Earth's oceans combined. The prospect that this moon could be home to life is no longer just a theoretical possibility, it's a hypothesis that continues to gather strength as evidence accumulates. Scientists believe that this subglacial sea, hidden beneath Europa's frozen surface, is not only vast, but also potentially habitable. The conditions on Europa, though harsh by Earth standards, may provide the right environment for life to exist in some form. When the Galileo spacecraft, launched by NASA in 1989, arrived in the vicinity of Jupiter, it brought with it a wealth of new knowledge about the gas giant and its moons. Among its many discoveries, the one that sparked the most excitement was the detection of disturbances in the magnetic field around Europa. These disturbances suggested that Europa's interior was not solid but rather contained a liquid layer beneath the surface. The magnetic field of Jupiter is a powerful one, and scientists were able to measure how it interacted with the moon's surface. The presence of a liquid layer was further confirmed by the fact that Europa's magnetic field was fluctuating in a way that would only be caused by a conductive liquid. Since Europa has no rocky crust, this suggested the presence of a subsurface ocean, not of molten rock, but of liquid water. Water is the essential ingredient for life as we know it, and its presence on Europa transformed the moon from an interesting, distant object into a prime candidate in the search for extraterrestrial life. But the discovery of water on Europa doesn't necessarily guarantee that life exists there. After all, water is a necessary but not sufficient condition for life. The real question is whether the water on Europa is in a state that could support life. The key to answering this question lies in understanding the forces at play beneath Europa's surface. One of the factors that makes Europa such an interesting candidate for life is the tidal heating that occurs as it orbits Jupiter. Europa has an elliptical orbit, meaning that it doesn't orbit Jupiter in a perfect circle. Instead, it moves in an elongated, oval-shaped path. As a result, Europa experiences constant gravitational interactions with Jupiter, and this causes the moon to stretch and compress as it moves along its orbit. This stretching creates friction within Europa's interior, and this friction generates heat. This heat is enough to keep the water beneath the ice crust in a liquid state, despite the moon's frigid surface temperatures, which can drop as low as -160 degrees Celsius -260 degrees Fahrenheit. The tidal forces from Jupiter, along with the friction generated by Europa's eccentric orbit, prevent the ocean from freezing solid, making it possible for life to thrive in an environment where temperatures are far colder than what we experience on Earth. The potential for life on Europa is also supported by the unique geological features of the moon. The surface of Europa is crisscrossed with long, dark lines and ridges, suggesting that there is active geological activity beneath the surface. This activity could provide the necessary energy and nutrients that would allow life to flourish. Some scientists speculate that Europa may have hydrothermal vents beneath its icy crust, similar to those found in the deep oceans of Earth. On Earth, these vents support thriving ecosystems that are not dependent on sunlight, but instead rely on the heat and chemicals emanating from the Earth's interior. If Europa has similar hydrothermal vents, they could provide the necessary ingredients for life, including heat, water, and chemicals such as methane, hydrogen, and sulfur. These chemical processes are crucial for sustaining life in environments that lack sunlight, and they may be the key to understanding how life could exist on Europa. Despite the promising conditions beneath the ice, the surface of Europa is far from hospitable. The Moon's surface is covered by a thick layer of ice, which is fractured and broken up by the movement of the underlying ocean. The surface is also bombarded by radiation from Jupiter's powerful magnetic field, which makes it an extremely hostile environment for any organisms living on the surface. However, the ocean beneath the ice is shielded from this radiation, which means that any potential life on Europa would likely exist in the subglacial ocean, far from the dangerous radiation of space. Scientists believe that the ice shell, although thick, may not be impenetrable, and that there may be areas where the ice is thinner or where cracks in the surface allow for the possibility of exchange between the ocean and space. This is where future missions to Europa could provide the crucial data needed to determine whether life exists on the Moon. One of the most exciting aspects of Europa's potential habitability is the upcoming Europa Clipper mission, scheduled for launch by NASA in 2024. This spacecraft will conduct detailed flybys of Europa, studying its surface and its ocean in unprecedented detail. Over the course of 45 flybys, the Europa Clipper will pass within just 25 kilometers of Europa's surface, gathering data on the Moon's ice shell, its ocean, and its magnetic field. This mission will provide valuable insights into the chemical composition of the ocean, as well as the potential for life in Europa's deep sea. One of the main goals of the Europa Clipper mission is to assess the Moon's habitability. Scientists are particularly interested in understanding the composition of the ocean, as well as the presence of essential chemicals that could support life. In addition to studying the surface, Europa Clipper will also search for signs of water vapor or plumes of ice erupting from the Moon's surface, which could indicate that the ocean is in contact with the surface in some way. This would provide a direct link between the ocean and space, potentially allowing scientists to analyze the water for signs of life without having to drill through the ice. Europa Clipper will also look for suitable landing sites for future missions that could land on Europa's surface and deploy probes to study the subsurface ocean directly. One of the most exciting possibilities is the use of a cryobot, a type of probe that would melt its way through the ice crust to reach the ocean below. This would allow scientists to send a mini-submarine into the depths of Europa's ocean, providing a close-up look at the conditions that exist beneath the ice. This type of mission is still a long way off, but it could be the key to unlocking the mystery of Europa's potential for life. As exciting as the Europa Clipper mission is, it will not reach Jupiter's orbit until 2030 at the earliest. This means that there is still time to refine the technology and strategies needed to conduct future missions to Europa. However, the Europa Clipper mission is an essential first step in understanding the Moon's potential habitability and will provide crucial data for future missions. The prospect of discovering life on Europa is an exhilarating one, but it's important to recognize that there is still much we don't know about the Moon. Despite the promising signs, there is as yet no direct evidence of life on Europa. The detection of water, organic compounds, and potential energy sources are just the beginning of the journey. The data gathered by the Europa Clipper mission will help to refine our understanding of the Moon's potential for life and provide crucial insights into the processes that might allow life to exist in such extreme conditions. While scientists remain cautious about jumping to conclusions, the excitement surrounding Europa's potential as a habitable world is palpable. If life does exist on Europa, it would be a revolutionary discovery, reshaping our understanding of life in the universe and raising profound questions about the origins of life itself. For now, the search for life on Europa continues, and future missions will undoubtedly provide more answers. The discovery of a subsurface ocean beneath the ice shell is just the beginning, and as we develop the technology to explore Europa more fully, we may one day find definitive proof of extraterrestrial life. Until then, Europa remains one of the most captivating mysteries of our solar system, offering a tantalizing glimpse into the possibility that life could exist far beyond Earth. The quest to understand Europa is a journey that will inspire generations of scientists and explorers, and its secrets may one day unlock the most profound questions humanity has ever asked. Are we alone in the universe, or is Europa's ocean teeming with life waiting to be discovered? Only time will tell, but the answers may be closer than we ever imagined.